We tend to view our digital privacy as a matter of individual effort, the length of a password or the complexity of a string of characters. This creates a feeling of total control. If the password is never shared, the door remains closed. We assume the system's primary job is to keep outsiders on the other side of that credential wall. But the most effective digital intrusions bypass the password wall entirely. They rely on the way a website recognizes a user after they have already logged in. This vulnerability is often a byproduct of convenience features, intentionally built into a platform's architecture to reduce friction for the user. In 2018, a major social media platform discovered that an exploit in its code had left 50 million accounts vulnerable to unauthorized access for years. The exploit originated from a specific privacy tool, the View As button. Engineers designed this feature to help users audit their own settings. It allowed a person to see their profile through the eyes of a stranger or a friend, confirming exactly what information was visible to the public. By providing this audit tool, the platform's code inadvertently allowed a person to generate the digital identifiers required to impersonate other accounts. The specific target of this exploit wasn't a list of passwords. The attackers were harvesting authentication tokens. Platforms use these tokens to avoid asking for a password every time a user refreshes their feed. Once a user logs in, the system validates a session token, a unique string verifying their identity. The server doesn't check for a password, it only verifies the token. If an outside party captures that string, the system treats them as the legitimate account owner. A user might see their account as locked because the login screen isn't visible. Meanwhile, the server sees an open session because the token confirms the user has already been cleared for entry. This digital memory allows us to stay logged into apps for months at a time, but it also creates a persistent point of entry that bypasses traditional security. In the 2018 breach, the View As tool contained a specific coding error. When a user viewed their own profile as a friend, the system accidentally generated an authentication token for that friend's account. Attackers used a script to automate this process. This allowed them to repeatedly trigger the View As feature and collect valid session tokens at a rate impossible for a human to replicate. The attack spread through the social graph. By hijacking one account, the script could use the View As feature on that account's friends list, harvesting the tokens of every friend, and then using those new accounts to reach the next layer of users. This automated cycle allowed the script to collect 50 million active authentication tokens. It was a silent harvest that required zero interaction from the victims. The same infrastructure designed to help a platform scale its social connections was now being used to scale the total compromise of its users. The reach of this exploit extended to the highest levels of the company. The attackers successfully captured the session token for the personal account of the platform's CEO. This gave them the ability to view private messages, access restricted profile data, and post content as the creator. To stop the script's progress, the company had to invalidate every active token in the affected pool. They forcibly logged out 90 million people in a single afternoon, effectively deleting the digital strings the attackers were using to hold the accounts open. It served as a stark reminder that even the people who build these digital systems are subject to the vulnerabilities hidden within their own architecture. These incidents aren't isolated errors. They are a recurring feature of modern digital infrastructure. In a separate case, an API flaw left non-public emails and job titles exposed for 3 years before anyone realized the data was being leaked. Right now, countless background processes are handling our data through APIs and session managers. These systems can harbor flaws that quietly expose information to anyone who knows how to request it. We have no way to verify if a session is truly secure, especially when the platforms themselves are still learning how to find these openings. True digital privacy remains a secondary concern as long as our systems are built to prioritize a frictionless experience over the rigorous verification of every single